for chapter 6.9, we're going to talk about patterns. We're going to look for patterns, okay? And our learning goal today is to identify, meaning to find, describe, meaning to tell about, and create, meaning you're going to make your own, number patterns with fractions. But before we get there, let's talk about the problem of the day. Mr. Patrick wants to develop a new chili recipe for his restaurant. Each batch he uses uses a different amount of chili powder. So he's trying to test out new recipes to see which one will be the best to serve at his restaurant. Okay. The first time he tries, the first batch, he uses 3½ ounces of chili pepper. The second batch uses 4 5/6 ounces. And the third uses 6 1/6 ounces of chili pepper. And then the fourth one uses 7½ ounces. If this pattern continues, how much chili powder will he use in his 6th batch of chili? All right, what is the problem asking? Liam, what's the problem asking?
How much chili would he have used in his 6th batch?
Right, okay, his 6th batch is going to be his spiciest yet because he keeps adding more and more chili powder. What important information do we need in order to solve this problem, Zara? Mm-hmm. Okay. Right. We can make a chart just like we did for our whole numbers to figure out what the pattern is. Okay? The first batch, he used 3½ In the second batch, he uses 4 5/6 In the third batch, he uses 6 1/6 ounces. And in the fourth batch, he used 7½ ounces. Now, go ahead and write these numbers in order in a chart like this in your notebook to take good notes. Are these fractions, do they have common denominators? Do they?
No.
No, our denominators are 2, 6, 6, 2. Why is it important to rewrite equivalent fractions so that they have common denominators? So step 1 is to write those fractions, write those numbers as equivalent fractions that have common denominators so that we can compare them, so that we can add and subtract and see how much there is different in between each one. So looking at those denominators, 2, 6, 6, 2, what could be a common denominator? Harshita?
6.
6, okay. So let's rewrite those fractions, those mixed numbers, as equivalent fractions that have a denominator of 6. 3½ is equivalent to 3 and how many sixths?
3.
3 3/6. You can see right here, batch 1 is right here. So 3½ is equivalent to 3 3/6. Okay, batch 2, 4 5/6. Do we have to change that denominator? No, we can keep it the same because it's already sixths. What about batch 3? Do we have to rewrite an equivalent fraction?
No.
Nope, so I can just write again how much? 6 1/6. What about batch number 4? 7½ is equivalent to 7 3/6. Okay. Now we can let's look at these numbers now that we all have equivalent fraction or equivalent denominators of 6, and let's compare how much has changed between batch number 1 and batch number 2. Okay. What's 6 1/6 minus 4 5/6? Go ahead and do that in your math notebook to check. 6 1/6 minus 4 5/6. Okay, so I had to add 1 2/6 in order to get from batch 2 to batch 3. Now, just because it's the same number, that doesn't mean it's a rule yet, because it needs to happen how many times for it to be a rule? 3 times. So let's try one more time. How do I get from batch 3 to batch 4? How did I get from 6 1/6 ounces to 7 3/6 ounces? Go ahead and do that math and then confirm whether or not this rule will still work. Is to write a rule that describes the pattern in this sequence. Okay, and in order to do that, we have to first ask ourselves, is this sequence, are these numbers increasing or decreasing from one number to the next? Are they getting bigger or smaller? Shreya? So if they're getting bigger, the numbers are getting bigger from batch 1 to batch 2 to batch 3 to batch 4. Does that mean that the numbers are increasing or decreasing? Increasing, okay. And so what is the rule then to get from one number to the next? Ariel?
1 2/6 or 1 1/3.
So the rule is 1 2/6?
Like increase.
I need to increase by 1 and 2 sixths, which means I need to do what? Add, subtract, multiply, or divide? Huh? Add. So my rule then is to add 1 and 2 sixths. Is that my final answer? Why is that not my final answer? Let's go back and take a look at the problem again. What was the problem asking? So step 3 is to extend the sequence, right? We have batch 1 here, batch 2, batch 3, batch 4, batch 5, and batch 6. So you're going to extend the sequence to batch number 6 in order to solve the problem.